Day 827 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3302. Find the lexicographically smallest valid sequence. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given two strings, word 1 and word 2. A string X is called almost equal to Y if you can change at most one character in X to make it identical to Y. A sequence of indices seek is called valid if the indices are sorted in ascending order. Concatenating the characters at these indices in word 1 in the same order results in a string that is almost equal to word 2. Return an array of size word 2.length representing the lexicographically smallest valid sequence of indices. If no such sequence of indices exists, return an empty array. Note that the answer must represent the lexicographically smallest array, not the corresponding string formed by those indices. All right, y'all. So before we take a look at the examples, let's take a look at the definition of lexicographically smaller. It says an array A is lexicographically smaller than an array B if in the first position where A and B differ, array A has an element that is less than the corresponding element in B. If the first min A or min B dot length elements do not differ, then the shorter array is the lexicographically smaller one. So just to make sense one step more, it's basically alphabetical order, but there's like a few extra steps after alphabetical order, right? So a string that starts with A is lexicographically smaller than a string that starts with B. And if the string A has 3 letters but B has 4 letters, that might make one string lexicographically smaller than the other if they have the same characters. So it's a lot to it, but once you get further involved and deeper into your programming journey, the lexicographically definition or the lexicographical definition will make more sense. But for now that we understand the question, or now let's take a look at the example. Sorry, y'all. Let's get into these examples. So in example 1, our input word 1 equals a string VBCCA. Word 2 equals a string ABC. So let me copy and paste this so I can show y'all, give y'all a better visual representation of what's going on. So boom, these are our two strings right here. Boom. So the output is an array of integers 0, 1, 2, and that comes from indices 0, 1, 2. So it says the lexicographically smallest valid sequence of indices is 0, 1, and 2. So we're going to change, remember, so we are allowed to change at most one character. Boom. So in this case, we're going to change indices 0 to A. So once we turn this V to A, boom, and we want the sequence to match word 2. So, boom. Let's just say word 2, word 1, boom. So, and then after we made that change, A and B are already B and C are already B and C at indice 1 and indice 2. So we already had the BC right here. So it says the valid sequence is indices 0, 1, and 2, right? This indices right here, 0, 1, and 2, are the indices that match word 2. So that's after we changed one character. So that's why we're going with indices 0, 1, and 2. Now, just in case that didn't make sense to y'all, let's take a look at example 2. So let's go ahead and do this. Boom, 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 boom. Okay, so this time we have our input word 1 equals a string BACDC, word 2 equals a string ABC. The output is an array of integers 1, 2, 4 for indices 1, 2, and 4. Explanation says the lexicographically smallest valid sequence of indices is 1, 2, and 4. It says word of 1 is already A. Now hold on now. Oh, sorry, yeah, we at 1. I'm looking at 0. So yeah, word of 1 is already A. We're gonna change word of 2 to B. Boom. So we change that to B, and then 4 is already C. Boom. So we're looking at 1, 2, 4 is gonna match this. Boom. So that's why we put 1, 2, 4 right there. Now, just in case that didn't make sense, let's copy and paste this over here. Let me see. Boom. Okay. So in example 3, our input word 1 equals the string A. Word 2 equals the string A, B, C. The output is a blank array. Explanation says there is no valid sequence of indices. So in this case, we could only, there is no valid sequence of indices because, let's see, it says, sorry y'all, because I'm trying to figure out why there is no valid sequence. Sorry y'all. Oh, sorry y'all, because there is no BC. No matter what we do, we cannot make this string equal to this string. We might could get the first 3 characters of this string, but remember, we need this whole string. So since we need this whole string and we can only change one of these characters, then it's impossible to find a valid sequence, so we return a blank array. Sorry about that. Then in example 4, our input word 1 equals a string ABC, word 2 equals a string AB. We can just take these indices right here. That's a valid sequence at indices 0 and 1, and that will match word 2. So boom, y'all. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we want to do is we're going to convert both strings to arrays of UTF-8 bytes for efficient indexing, and then we're going to drop the last to remove the null terminator added by the UTF-8C string. So we'll come right here. We'll say let word 1 equal word 1 dot UTF-8C string dot drop last, put parentheses. Boom. Then really we could just copy and paste this, but make sure to change word 1 to word 2. So we can change this to a 2, change this to a 2. Boom. Then we'll come underneath this and we're going to say let n equal word 1 dot count, let m equal word 2 dot count. Boom. Now we're going to come right here and we're going to create a variable that will store the earliest index in word 1 when we scan backwards, where word 2 can be matched while still allowing the remainder of word 2 to be matched after. So we're going to declare a variable called last, colon. It's going to be an array of integers. Boom. We'll set that, or we'll initialize it with an array, open under parentheses, repeating, colon, -1, comma, count, colon, m. Boom. Then we're going to start matching from the end of word 2 by declaring a variable called j and set that equal to m minus 1. Boom. Now we're going to walk backwards through word 1, recording where each suffix character of word 2 can be matched. So we're going to say for I in stride, open up the parentheses, from, colon, n minus 1, comma, through, colon, 0, comma, by, colon, -1, come outside of that. Open up the brackets and we'll say if j is less than or equal to 0, comma, word 1, square bracket I, equals word 2, square bracket j. We'll open up the brackets and we'll say last square bracket j equals I. Boom. Then we'll say j minus equals 1. Boom. Now we're going to store the indices selected from word 1 by coming right here. We're going to create a variable called res, colon. It's going to be an array of integers, and we'll set that equal to a blank array. Now we need to count how many mismatched characters have been used. The algorithm allows at most one mismatch. So we could come right here, just declare a variable called skip. We'll set that equal to 0. Then we're going to restart matching from the beginning of word 1. So we're going to say j equals 0. Then we're going to scan through word 1 from left to right. So we're going to say for I n 0 dot dot less than n. We're going to open up the brackets and stop once every character of word 2 has been matched. So we're going to say if j equals m, we'll open up the brackets and we'll break. Then we're going to take the current character if it matches the current character of word 2, or we haven't used our one allowed mismatch yet, and choosing this mismatch will still leave enough room to match the rest of word 2. So we'll come underneath this. We'll say if, open up the parentheses, word word 1, square bracket I, come outside of that, equals word 2, square bracket j. Will come outside of that, vertical line, and we'll say skip equals 0, and 2 and signs. We'll open up the parentheses and we'll say j equals m minus 1, or 2 vertical lines, I is less than last square bracket j plus 1. Boom. Then we're going to record if this character was actually a mismatch. First we're going to come right here, open up the brackets. Then we're going to record if this character is actually a mismatch. So we're going to say skip plus equals word 1, square bracket I. Come outside of that, does not equal word 2, 2 square bracket j, question mark. So this is going to return a Boolean. So if that's true, or if it's not true, or if this not true holds to be true, then we'll come right here, we'll say 1. If not, we'll say colon 0. Then we'll save the chosen index by saying res dot append, open up the parentheses I. Then we'll come underneath that and we'll say j plus equals 1. Boom. Then we're going to return the selected indices only if all the word 2's match. So we'll come right here and we're going to say return j equals m question mark res colon blank array. So once again, if this holds true, we'll return res. If it's false, we'll return a blank array. Boom, y'all. That should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. First try. I love that. And look at that, y'all. 14 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. Oh, that's the bottom part, actually, y'all. So, yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.